Okay, so today we are covering Unit 11, Day 3 notes. We're going to be finding the area of composite figures and some shaded regions. You can find all these notes on OMHS, as well as the key. And you're going to want to have your formula sheet nearby because we're going to be using some formulas from that sheet. So if you have that formula sheet printed, or you can open it in another tab, however, you can have that formula sheet close by. Okay, and we're going to be finding areas of composite figures. Okay, so what is a composite figure? Okay, so a composite figure is pretty much just a shape or a figure that you can separate into regions that are the shapes on your formula sheet. So we're going to see shapes today that are not on your formula sheet. But what we're going to do is we're going to separate them into shapes that we do know. So maybe you'd see this funky shape, but you can break it up into triangles or parallelograms, trapezoids, rectangles, or even circles. And what you're going to do to find that area is you're going to divide up the regions. So like draw the lines in the picture so that you can see those different shapes. And then you'll find each area. And then once you know the area of each of the shapes, the total area will just be the sum of your regions. Okay, pretty simple. So in number 1, we got this like really funky looking shape, right? So Monday's lesson. Monday's lesson was finding the area of regular polygons and breaking that up into triangles. So that's kind of like that, except we're going to see more than just triangles. Yeah, but good connection. So in number 1, we have this like weird, I don't know, upside down house looking shape, right? What we're going to do is we're going to break it apart into shapes that we know. So looking at number 1, what shapes do you see in my figure that are on the formula sheet? You can type it in the chat. What do you see? Do you see circles, rectangles, squares, triangles, trapezoids? Nice. Yay, yes. All right, so if you are saying rectangle and trapezoid, I completely agree with you. So what I'm going to do is I'm going to break this shape up into, I'm going to call this region 1, and I'll call this region 2. So I've got 2 regions or 2 figures. We're going to find the area of the first region, and then we're going to find the area of the second region. And then after we have those 2 areas, we're going to add them together to get our total area. Okay, so let's find the area of the rectangle. So you look at your formula sheet, you find the rectangle, and the area of a rectangle is length times width. So to find the area of this rectangle, we can say 12 times 23. Or if you did 23 times 12, you're going to get the same answer. So the area of the rectangle is 276 centimeters squared. Now we find the area of the trapezoid. So the area of a trapezoid, we look at our formula sheet, we find the trapezoid, it's 1/2 times the height times the base plus the base. All right, so the bases aren't too difficult there. One's 15 and one's 23. The height, though, is not labeled. I know that this height is 12. And I know that from here to here is 18. Yeah, you got it, John. So the height has to be 6 because the distance from here to here, right, has to, whatever it is, I have to be able to add it to 12 to get that 18. So it's 6. So in these composite figures, they might not always give you every single number that you need, but there will be enough information in the picture that you can figure it out. Yeah. So now we just find the area of that trapezoid. Hey, calculator, 15 plus 23 times 6 times 1/2 is 114. So the total area is going to be the area of each region summed or added together. So 276 plus 114, 390. And our units, it's an area, so it's units squared. Easy as that. Looking at number 2, what shapes do you see in number 2? Yeah, so you add the 2 areas at the end to find the total area. Yep. I see 2 half circles, yes. I don't see any rectangles though. Parallelogram, there, someone got it. 2 half circles and a parallelogram. So just watch out, this shape right here. Right, that's not a rectangle. Rectangles have 4 90-degree angles. Yeah, so just watch out for that. That's okay. So I'm going to call that rectangle region 1, or not, now you're making me say rectangle. I'm going to call that parallelogram region 1. And then 2 half circles, right? And here's a half circle, and here's a half circle. Well, 2 half circles make 1 whole circle. So you could find the area of half a circle and then the area of half a circle, or you could just find the area of the whole circle, since together they make a whole circle. So I'm just going to call them together region 2. So we'll find the area of the parallelogram. We'll find the area of the circle. And then we will add them together to find the total. How do you know they're congruent? Well, they have the same diameter, right? The diameter of this half circle is 12, and the diameter of this half circle is 12, because it's a parallelogram. So since they have the same diameter, they have to be the same size. That's a really good question. If you recognized it as a triangle and a trapezoid, it's okay to recognize those shapes for sure, but I would definitely caution you, because if we did a triangle, a trapezoid, and a circle, you're going to be missing information, because we don't know the length of this piece right here. We know that from here to here is going to be 12, but we don't know just this piece. So if you're seeing some triangles and trapezoids, think outside the box. And maybe also don't forget about that parallelogram. Parallelograms are our friends too. All right, so let's find the area of the parallelogram. Think outside the parallelogram, Lydia says. So we look at our formula sheet, and the formula sheet says that the formula sheet says the area of a parallelogram is what base times height, right? Remember, your height is always perpendicular to your base. So in this case, what would the height of that parallelogram be? Here, I'll let you point to it, because, yeah, let's point to it. Point to the height of that parallelogram, would you? Yay, you're right. The height is the distance between the bases, and the bases in your parallelogram are your parallel sides. Well, I mean, they're both parallel, but we know that this 5 is perpendicular to the 12. Perfect. You guys got it. Thank you so much. So our height is 5, and I keep saying 12. Where am I getting 12 from? Right? I see a 6. Miss Grandy, it's a 6. Why do you keep saying 12? Well, it's labeling the radius, right? This is a radius, which means this is a radius, which means that's also 6. So the length of the whole thing is 12. Okay, so for our parallelogram, we've got 12 times 5. Clearly my key on OMHS has wrong numbers on it. So if you're looking at the key on the OMHS, I gotta fix that. Okay, so 12 times 5 is 60. So we get 60. Okay, so the area of that parallelogram is 60. And now we have to find the area of the circle. So the area of the circle is pi r squared, and we know that the radius is 6. So an exact answer in terms of pi would be 36 pi. If you rounded it to the nearest hundredth, like it says to do in the directions, we'll just do 36 times pi. And let's see, what do we get? 113.10. So our total area there is, and you'll see me write it like this, area subtotal, right, is 173.10. Okay. All right, now if you really wanted to find the area of each half circle and then add 3 shapes together, that's fine. You're going to get the same answer. Okay. Then they start getting crazy with these shapes, right? Like, let's just put all these random shapes together and find the area of it. So looking at number 3, I see 3 regions. And I see a rectangle. So I'm going to call that region 1. I see a triangle. I'm going to call that region 2. And I see a semicircle or half a circle. And so I'll call that region 3. So then I'm going to find the area of each of those regions, the 2, and add it all up. Mariah, I missed what you said. Yeah, okay, I'm going to go back a slide just for a second. Did you get it? Perfect. All right. So let's find the area of the rectangle. To find the area of a rectangle, you need a length and a width. So that 9 is very nice. Thank you, 9. But now we need to figure out the width. I need this length. Okay. Well, I know that this is not, oh, you can't see where I'm pointing. I know that this is 9, which means in my rectangle, this piece is also 9. How does that help? Well, that's the radius of that semicircle. And every radius in a circle is equal. Yeah, Lydia's got it. So that means this length is also 9. So if this is 9, then we can figure out the length of that rectangle. Yeah, I'm showing you examples because these are probably things that maybe you didn't think of right away, but it'll help you on future problems, I bet. Yeah, so 26 minus 9 tells me that the length of that is 17. So 9 times 17 is 153. So the area of that rectangle is 153. All right, let's look at my right triangle. The area of a triangle is 1/2 base times height. All right, so in a right triangle, your base and your height are perpendicular to one another. Okay, so that base is a radius of the circle. That's 9. That's nice. And now we have to figure out the height. Okay, well, this piece right here is 7. And we know that the length of the rectangle is 17. So what's going to be the height of the triangle? Yeah, you guys got it in the chat. 10. Good job. So now we can find the area of the triangle. 1/2, 9 times 10, 45. And then we do the semicircle. There isn't a semicircle on your formula sheet. So how could we find the area of a semicircle? Can't break that up into triangles or squares. What do you think? How would you find the area of a semicircle? Half of the circle. Perfect. So you're going to take your formula for area of a circle, pi r squared, and then divide it by 2 or multiply it by 1/2. Same thing. So whatever the area of your circle is, The area of half a circle will be half the area of the whole circle. Yes. Okay, so 1/2 times pi. The radius we've been saying is 9. So about 127.23. All right, so that's all of the regions. So now our final answer, find the total area. So just add all of your areas together. 53, 45, 127.23. Yeah, Lydia, you had it. 325.23. And don't forget your units, feet squared. On an assessment, those units will be taken care of for you. You're right. The next one does make me hungry for ice cream, Navira. I completely agree. All right. Looking at number 4. You knew what I was going to ask. We see triangles and a semicircle. So let's just break it up into our regions. I'm going to call that semicircle region 1 and my triangle region 2. And if you chose to switch it and call the triangle region 1 and the semicircle region 2, that doesn't really matter. All right, let's find the area of our region 1. So that's a semicircle. So that's half of a whole circle. The radius here is not given, but the diameter is. The diameter is 16. So that means the radius, of course, would have to be 8. So you'd have to divide that by 2, yeah. To the nearest hundredth, we get 100.53. Okay. Now the triangle. Okay, now this one's a little trickier because for a triangle, it's 1/2 base times height. They didn't tell me the height. So we have to figure that out. So I'm going to draw the height into my triangle there. Oh yeah, okay. Here it is. Okay. How could I find the height of my triangle? What do you think? Yeah, Haley, Hannah, you got it. As soon as I did that, I'm hoping that you saw that my right triangle. We don't know the height, but we know this length is the radius of the circle, or 8. We know that the hypotenuse of that is 17. So our dear friend Pythagoras, who says that the hypotenuse squared equals the leg squared plus the leg squared. So let's see, 17 squared is 289. Subtract 64 from both sides, 225 equals x squared, and square root each side. So the height of this guy is 15. Now we have what we need. So the base of that triangle, 16. The height we just found was 15. So the area of the triangle is 120. So now we just need our total area. So add your 100.53 and 120, 220.53. Nice. Any questions about anything that you've seen up here on the screen before I go on? Nope. Okay. Let's look at number 5. What shapes do you see in number 5? Oh, I forgot the units. My last. It's okay. Okay, I see a square. I see a triangle or triangles, depending on how you want to look at it, and a trapezoid. Wonderful. So if you see one triangle, maybe you're looking at this whole thing. If you see 2 triangles, Maybe you're looking at these two little guys. I'd like you to try this problem. Look at your square, look at your trapezoid, and look at your triangle or triangles, depending on how you're looking at it, and find the total area. I'll give you a couple minutes to work on it, and then I will put mine up here and we can compare answers. Okay, so let's take like 5 minutes. That's probably more than enough. And then we'll go over it. Okay, so I'll try this one. All right, if you're still working, that's okay. I'm going to start to put mine up here on the board and kind of talk through it a little bit. But if you're still working, go ahead and finish, and then you can check yours with mine. Okay, so I had a lot of people give me all the right shapes, which is good. We know our shapes as 9th, 10th, 11th graders. But we had a square, we have a triangle, and we have a trapezoid. And I personally called that triangle one shape. So I have the square, I called that region 1. And then I have the trapezoid, which I called region 2. And the triangle, the whole thing, I called that region 3. And if you had those numbers different, that's okay. So to find the area of a square, you need to know the length of the side. But I don't know the length of the sides. I know that from here to here is 25.4, but I don't know the length of the side of the square. So I'm going to come back to the square. The trapezoid, I need 1/2 times the height. Well, I don't know the height. I know that from here to here is 25.4, but I don't know the length of the square. So that's not helpful. And I wouldn't know this base. So let's come back to the trapezoid. Oh, I hope the triangle helps us out. It does. Okay, so looking at the triangle, okay, I'm going to redraw the triangle just up here as best I can. I know that the height of that triangle is 9.6, and I know that the side here is 12. So yeah, we're going to use the Pythagorean theorem to find this side right here. See the right triangle? So we'll call it x. Hypotenuse squared equals leg squared plus leg squared. Yep, and we get 7.2. So when you square, right, 12 squared, 9.6 squared, for those of us who just want to see it, 92.16. Subtract 92.16 from both sides. Oops. And then take the square root of both sides. Of both sides. So you get 7.2. All right, so that tells me that this piece is 7.2, which means the entire base of my triangle has to be twice that. Okay, so if this piece is 7.2, that means this piece is 7.2. So the whole thing is 14.4. That unlocks the entire problem for us, because once we know this base, now we know the length of each side of the square, and we know the second base of our trapezoid. So let's just go ahead and figure out that triangle. The area of a triangle is 1/2 times the base, 14.4, times the height of that triangle, 9.6. So the area of the triangle is 69.12. Great. Now we know that the length of each side here is 14.4. So now I can find the area of the square, length times width, or side squared, however you want to look at it. So the area of my square is 207.36. And then the last part, the trapezoid. So now I can figure out the height of the trapezoid, because I know that from here to here is 14.4 and the whole thing is 25.5. So when you subtract 25.4 minus 14.4, you get 11. So the height of your trapezoid is 11, and your bases of your trapezoid are 10 and 14.4. So someone in the chat said, well, isn't 10 a base of the trapezoid? It certainly is. And so if 10 is one of the bases, we need to know the other one. If your bases in your quote unquote trapezoid are the same length, it's not a trapezoid anymore, right? It'd need to be a parallelogram or a rectangle or something. Okay. So the area of your trapezoid is 134.2. Yeah. Okay. So now your total area, Haley, check that number. Your total area should be 410.68. In units, so I don't forget them this time, meters squared. All right, so here was an example where, yes, it was missing a piece of information, but once we use that Pythagorean theorem, it really unlocked the whole thing for us. So if you find yourself missing a piece of your shape, go on to another shape. And if you're missing something from that one, go to the other one, because something will eventually, you'll be able to figure it out using probably the Pythagorean theorem or some other method and unlock the rest of it. Nice. All right, so that's composite figures. Pretty much just break it apart into shapes that you know, find the area of those shapes, and then put them all back together. The next part of our lesson is to find a shaded region. Okay, so before we even fill this in, I made, I don't know, I'm not super creative, but I made something here for you to see. So I'm gonna share my screen. Here it is. Oh, so exciting, a nice gray square. Okay. Mrs. Grandy has a gray Post-it note. I don't know, very rare Post-it notes. They're gray now. And she wants to cut a circle out of it. So she draws a circle on her Post-it note. And that circle has a diameter that is the same length of the Post-it note. So she gets out her handy dandy scissors and she starts to cut out that circle. Now she has these pieces of leftover gray Post-it note that are staying together on the screen, but in reality would just fall apart into 4 little weird looking triangle looking pieces, right? And then she has a nice gray circle. How much area of Post-it note did she waste by cutting apart that Post-it note for this circle? How much paper is she throwing away? Okay, so let's talk about what I would do, right? Let's start at the beginning. Start off with my very rare vintage gray Post-it note. I don't know, making it up. What would I do to find this Post-it note that I'm throwing away? Valeria says, find the area of the square, find the area of the circle, and subtract. Exactly. Did you hear me say the word take away? I took that circle away from the Post-it note. Well, we know that taking it away is another way of saying subtract. Okay, I'm hoping that my visual here is helping you kind of figure out what's going on. We start with a figure. We cut another figure out of it, and we take their areas away. This is kind of the opposite of what we were just doing, right? Before I said find the shapes, find their areas, and add them together. Well, now we're going to find the shapes, find their areas, and subtract them. And the reason I'm subtracting them is because I'm taking that shape physically away. Oh, I even got super, you look. Here it is. There it started whole. And now I'm going to take the circle away. I'm going to keep the circle and I'll throw this part in the trash. I should have made it yellow. I don't know why I chose gray. I don't know. Okay, so hopefully it gives you an idea of what's going on. And now we can go back and actually do what we were working on. Oh, I hope it saved my work. Nope. Cool. Oh, well. So, a shaded region. To find the area of your shaded region, you're going to find the area of the entire figure. Then subtract the area of the non-shaded regions. So before we do any more practice problems, your attendance word today is figure. There it is. Your attendance word today is figure. F-I-G-U-R-E. Write that down, circle it, highlight it. Figure. Go figure, huh? All right, so let's do our example here. Number 6. We have our gray Post-it note that we're going to cut the circle out of. Okay, it's a really big Post-it note apparently because it has 25-foot side. Okay, I got to stop calling it a Post-it note now. So from here to here is 25. Well, that means that from here to here is also 25. Okay, so the side of that square is also telling me the diameter of my circle. That's going to be very helpful in a moment. We're going to find the area of the square. We're going to find the area of the circle. And then to find just that shaded part, we're going to subtract. So we look at our formula sheet. We see that a square is really a rectangle. And so its area is length times width, which just happened to be the same. So the area of my square is 625. We'll put units at the very end. Now let's find the circle. The area of a circle is pi r squared. And this is why we need to know the diameter of that circle. The diameter of circle is 25, which means that our radius is 12.5, half of 25. Okay, so we get 490.87. So I have some students that say, well, do I subtract the square from the circle or the circle from the square? Here's really how you know if you did it wrong. If you have negative area, you subtracted wrong. You should never have a negative area. Okay, so we're taking the circle away from the square. So we're going to say that the shaded region is the area of the square minus the area of the circle. 625 minus 490.87. So our shaded region area is 134.13. And if you happen to think of that mixed up, hopefully if you were ever to get a negative area, that would throw off some red flags for you. Yep. So we're subtracting the circle from the square. All right, let's look at number 7. What shapes do you see there in number 7? A triangle. Yep, I do. I see a triangle. And a rectangle. Yes. So let's find the area of the rectangle. We'll find the area of the triangle. And then to find the shaded part, we will subtract. All right. So let's see here. Area of the rectangle is length times width. Those are labeled for us. That's nice. So the area of the rectangle is 350. You look at a formula sheet. The area of a triangle is 1/2 base times height. The base here isn't labeled, but we know what it is because it's a rectangle. These two lengths have to be the same. So this is 25. The height of my triangle is perpendicular to that base. That's 11. So the area of the triangle is 137.5. So our shaded region is going to be the area of the rectangle minus the area of the triangle. 350 minus 137.5. Very good, 212.5. Units, it's still area, so centimeters squared. Nice. Ooh, some of our circles unit is about to come back to play here. That's fun. All right, unit number 8. I see a semicircle, so I'm going to need to find the area of that. Hopefully you can read my writing there. And I see a triangle, so I'm going to find the area of that. So to find the shaded part, we're going to subtract the triangle from the semicircle. What kind of triangle do you see there? Yeah, Lydia's got it. Navira is on to me. Yep. If you said right, you are right. It's a right triangle. But Miss Grandy, how do we know it was a right triangle? There's no marking. You can't assume this is a right triangle. How did you know that? Okay, so let's just think for a moment. I have a semicircle, half a circle, right? Which means this is the diameter. If the rest of the circle was there, it would be down here. So this is your inscribed angle, because its vertex is on the circle. And an inscribed angle is half of the measure of the arc inside of it. And the measure of half a circle is 180. Yep, half of 180 is 90. So this inscribed angle is half of 180, or 90. There was a shortcut to that said if you have an inscribed angle that intercepts your diameter, it will be a 90-degree angle. For the exact reason that I just told you. It's intercepting half a circle. All right, so it's a 90-degree angle. And as soon as we know it's a right triangle, then we can use the Pythagorean theorem to find our hypotenuse. So the hypotenuse is what we don't know. I'm going to call that x. Equals leg squared plus leg squared. I'm hoping that we're getting really good at this Pythagorean theorem thing. The diameter turns out to be 23.4. Yep. All right. So now we know the diameter is 23.4. Let's find the area of half a circle. So a whole circle is pi r squared. Half a circle would be half pi r squared. But we know the radius. The radius is, what's the radius? 11.7. Very good. Couldn't trick you. It's half the diameter. Very good. So now the area of half of our circle is 215.03. I rounded to the nearest hundredth. Okay, now we got to find the area of the triangle. Area of a triangle is 1/2 base times height. I'm going to redraw the right triangle. Probably have to erase it in a minute. But if I redrew that right triangle with the 9, the 21.6, and the 23.4, could you point to the base and the height of that right triangle? Yeah. Someone point to the base, someone point to the height. You got it. Yeah, very good. The hypotenuse is not your base or your height. And the hypotenuse is 23.4. That's the longest side. And it's across from the right angle. So watch out for that, Navira. Thank you, guys. In a right triangle, your base and your height will be the legs of your triangle because your base and your height are perpendicular to each other. And in a right triangle, those are the legs. Okay, so to find the area of this triangle, it's 1/2 base times height, 9 times 21.6. So the area of my triangle is 97.2. So total area, or shaded region, is going to be the area of your half circle minus the area of your triangle. 215.03 minus 97.2, 117.83. Units are meters squared. Does it matter what side you call the base versus the height in a right triangle? No, it doesn't, Haley, because multiplication is commutative. So if I type 1/2 9 times 21.6 and you type 1/2 times 21.6 times 9, we get the same number. So yeah, in a right triangle, that doesn't matter as long as they're perpendicular to one another. All right, now if this was a multiple choice question, 117.83 clearly would be one of your choices, but if you added these together, that would be one of your choices too. So you just got to keep in mind, what am I finding the area of? Am I finding the area of a half circle plus a triangle, half circle minus a triangle? You just kind of got to keep your goal, your end answer in mind, what you're actually finding. All right, let's see here. Number 9. I'd like you to try number 9. Number 9. Let's find the area of this shaded part. All right, let's do it. We can do it. I'll give you like, I don't know, 4 minutes on this one, and then we'll go over it. All right, if you're still working, that's okay. I'm going to go through my process, and if you're stuck on a piece of it, maybe my process will help unstuck you. Does that make sense? Okay. So we know that we need to find the area of the trapezoid. Okay. And I'm not really good at drawing trapezoids, so I'm going to write trap. And then we're going to find the area of the semicircle, and we're going to end up subtracting, and that'll be our answer at the very end. So let's find the area of the trapezoid. But for the trapezoid, we need 1/2 times its height times the sum of the bases. All right, well, one base of my trapezoid is 37, and the other base of my trapezoid is 17, but I don't know the height. So some of you in the chat were asking me about finding the height, and maybe my little black dashed line helped here. I'm hoping that when I did that, you recognized, oh, there's a right triangle right there, right? So in that right triangle, the hypotenuse is 25. The height is what we're looking for. And well, what's the length of this side? Well, if this piece right here is 17, that means here is 17. So what's left? 20. So now I can find the height using Pythagorean theorem. Hypotenuse squared equals leg squared plus leg squared. And you get 15 is the height. All right, so if the 15 is the height, then I can put a 15 here and find the area of the trapezoid. So the area of the trapezoid becomes 405. Yay, good. Now we got to find the area of half a circle. All right, well, a circle is pi r squared, so half a circle is half pi r squared. So if this distance right here is 15, that means this is 15, which means that my radius is half of 15, 7.5. So half of my circle area is 88.36. So our shaded region, we're going to take the area of that trapezoid and subtract that half circle, and you should get 316.64. Your units are inches squared. Some of you gave me some really close answers. Some people I think may have accidentally added their areas together, so watch out for that. Some people may have found the area of this triangle, this square, added the square and the triangle together, and then subtracted the circle. I mean, it's not a square, it's a rectangle. So the rectangle and the triangle, and then subtracted out the half circle, that's okay. As long as you still get the same number, then you're fine. Okay. So it's really just a big puzzle, and if you're missing a piece, you got to just figure it out, like calculate it. There's always going to be enough information in the picture to figure out that missing piece. Okay, that brings us to the end. Very cool. All right, there's an exit ticket waiting for you. There is an attendance quiz for you. This recording will be posted, we'll say by 3 o'clock today, as long as the download goes quick. And if you have any questions, you can reach out to me. I'm happy to help. If you have any questions about Monday's Play Posit, you can ask me those too. Not right this second, but you can email them to me or join me in office hours on Tuesday. Awesome. It was great seeing everybody. Let me know if you have questions, and